This is a test to show what happens when the wrong type of thermocouple wire is used between a gauge and a thermocouple, which is located here. The correct type of cable is what's called a thermocouple extension cable, and it's got the correct wiring inside so that it does not create a cold junction at this location here. This location is subject to heating from the turbine, as is this, but at a greatly reduced temperature. However, it is enough of a temperature rise to cause a inaccuracy in the reading from the thermocouple if the wrong wire is chosen. And this is the way we can test it. You can see that we have 75, 76 degrees here at room temperature, and that's what the tip of the thermocouple's at. And we're going to heat this junction here, and we're going to watch the temperature. So I don't know what those nuts are at right now, but we can see there's a slight drop in indicated temperature, and those nuts are probably several hundred degrees right now. So we can see what's happened there with the thermocouple extension wire installed. We got about a 10-degree drop in temperature, which at turbine output temperature range is a very insignificant number percentage-wise. Now we're going to go ahead and change over to the non-thermocouple extension wire, and we'll see what kind of error we get. We're back now with the thermocouple wiring exchange, and we're now using the thermocouple wire that was supplied in the kit with this cloth jacket on it, and the wire looks like it's of a very old vintage, but the integrity is still there, so there's nothing wrong with the wiring per se, except that it's not thermocouple extension wire. And to prove that, we're going to do the same test that we did earlier with the thermocouple extension wire. We're going to heat up this junction right here, and we're going to watch the temperature of the readout, and we're going to see how far that drops. So we're heating it up, and as you can see, the temperature is dropping quite a bit. So there's some indication difference there in the meter, and we're going on 75 degrees almost worth of error when heating the back side of this, which proves that in this configuration with this supplied wire, this is actually the cold junction instead of the other side of the wire as with the thermocouple extension wire. Here is another configuration using just plain old copper wire at the terminals, and we'll see how that reacts to heating those terminals. It looks like it's reacting very similarly to how it did with the other wires that were supplied with the kit. And here is the final configuration that will be tested. This is a actual thermocouple wire, and that can be used as an extension wire also. So we're going to see what that does with the application of heat to the junction here. You can see that this is quite accurate using this type of wire. I'm heating that up to the same temperature that the other wire was heated up to, and it is just rock solid. And again, this is actual thermocouple wire. So I'm just heating away and it's staying put. So it's definitely displaced the cold junction to the other side of the thermocouple wire, which is connected to the meter. Now, something interesting about this thermocouple wire is that if you don't know which side the negative is, it's easy to find out. Thermocouple wire has one conductor that's magnetic. The other conductor is not. And likewise, on the sensor, one of the conductors or posts is magnetic, and it happens to be the negative. So if you ever want to figure out the polarity of a sensor or the sensor wire, if it's thermocouple wire, you can use a magnet. Now, thermocouple extension wire will not do that. It's not magnetic. It's not magnetic, so you have to trust that the color coding is correct, and red is negative on a K-type thermocouple. Yellow means it's K-type, and that's the positive.